Um, I'm Ty, and I'm just going to do a quick overview on how I use Docker and Docker Compose to build environments for my development, specifically Python, data science applications, and I'm going to be doing this through Jupyter Notebooks. Is going to be kind of the way. It's honestly the way I normally just kind of develop some scripts and play around in Python. So I'm going to go through a couple reasons of why I chose this method, and it works really well for me. It really does. Um, and we're going to do a very high level overview of Docker. This is not a Docker class. There's plenty of other resources out there. Brett Fisher's an excellent resource on Docker. And then I'm going to kind of do a little bit of hands on and show you why I think it works really well, or at least it works well for me. I'm going to go ahead and say I understand Docker may not be the answer for everyone, and that's perfectly okay. This is how I use Docker and why I like it. And so we're going to start off here. So, okay, why I like kind of our contents, the things I'm going to run over really quick. Why I like Docker for development. There's no virtual environments. It's easy to track your packages. It's insanely easy to collaborate. And it's easy to take what you build and deploy into an application using containerization. It's great. Uh, to understand some of this, we're going to do a very, very high level overview of Docker, and then I'm going to do a very quick hands on. All right. I hate virtual environments. I've said it. Um, they're it's for me. It's just a pain to configure and manage all the time, especially when I have a habit of working on multiple projects at any one time. So to go into the command line and build a virtual environment and name it and keep track of what I've named everything, especially when I'm split between projects at any one point in time, it can be very overwhelming just to keep track of what virtual environment has what, especially as I go in and maybe I'm trying a new package and I don't like that package and then I need to get rid of it and then I need to uninstall it from the virtual environment. It's just a lot of work for not a lot of payoff, in my opinion. Once again, this is me. If you like virtual environments, awesome, continue using them. But for me, they just don't work that well. I have tried Anaconda. I know you were asking that. I think every early data scientist has tried Anaconda, and I don't want to speak ill of Anaconda. I think it's really a good program, but when something goes wrong, more often than not, you have to reinstall the entire application. And launching Anaconda, especially the navigator, is so slow. I do love the environments tab. It's pretty cool. I really did like that, but just there were so many other problems built into Anaconda. Um, it just became more hassle than it was worth. I even tried Miniconda, and that was even worse. I like things to be very lightweight. I don't like a lot of bloat on my system. Um, and I don't like a lot of hidden packages. In fact, on my base system right now, I have Python installed and no other packages other than Kite uh, for development and text highlighting and syntax highlighting and things of that nature. But I really don't have anything else, and that's done specifically because I do not want a lot of bloat on my system. Personal preference, once again. Okay, so there's a couple of reasons why I really don't like virtual environments. I've tried Anaconda. Package tracking. Package tracking inside of a virtual environment is painful, in my opinion, and more painful than it should be, in my opinion. But they're smarter than people than me develop that process. I like to be able to go in and open up a file and see what packages I have, and more specifically, what versions I have. So I just did a quick snippet here of a requirements text. For me to track the packages I have pip installed within Docker, I go to my requirements txt folder. I don't need to pip freeze, don't need to do any of that. And this has the added benefit of the way I have this built out within that requirements text is I can actually say, okay, give me pymongo 3.12 and give me .0 all the way up to 3.13.0. So basically, don't do any major version changes, just do your security updates. And that's what I really like. And I manage this all through my requirements.txt folder or file, which is awesome in my opinion. I can visualize everything. I know exactly what's going into that container and what's missing. Collaboration. This was something I found out. These are all problems, right? Virtual environments was a problem for me. Package tracking was a problem for me. Collaboration was a huge problem for me. So let's just take a look at collaboration between Bob and Linda here. Bob has built a file. He's built a Python project and he needs to share it. Well, you go, okay, just use Git. Cool, Git's awesome. And in fact, Git is how I share a lot of this stuff out. But okay, so Bob goes ahead and does his Git push. Linda pulls it down from the repository. Well, now things you got to consider. What Python version are we using, right? Okay, is Bob on 3.9 and Linda's on 3.10? Well, that's not a problem. Backwards, everything that works in 9 should work in 10. But what happens if Bob's working 10 and Linda's on 9, and Bob's using the new match case, right? That's not going to work for Linda anymore. She needs to upgrade. But maybe if she upgrades, it's going to break something on the back end. Maybe she has another project she's working where that she needs to use Python 3.6 for some reason. So this is really an also way of managing your Python versions, because every Docker container will be built with a specific Python version. Package version. This is actually the thing that got me started using virtual environments. Was I'd be working on one project and it required a specific package version because it had a dependency built upon something else, and it was just kind of this chain effect where if I upgraded to a new package, it broke everything. So not only can I keep my Python version, the version for the project it needs to be, I can also track my packaging versions, as we saw in the virtual slide. Virtual environments. Managing, sharing, collaborating virtual environments is very difficult. And then OS versions. I know this shouldn't be an issue, but I have run into it where I work off a Windows machine, and I was collaborating with someone who had a Mac, and somewhere in that one of those packages, there was a version for Windows and there was a version for Mac, and it was very difficult for us to share that way. It was a really one-off issue, but the real benefit here is because I won't say all, because there are Windows containers for .NET environments, but containers as a general rule are built within a Linux environment. So even though I'm running Windows, my container is running in Linux. And if I give that package, or I give my Docker file to someone who is running a Mac, and they just run up Docker, they're running in Linux. So we're all speaking the same OS language, which is absolutely critical. So by using this methodology, we can keep our Python, our package version, we don't worry about environments, and we can keep all of our OS is on the same page. And if you think this is difficult between two people, what happens if you have a whole team of 5 people all collaborating on the same project? This very easily can spiral out of control. But that's why using Docker really helps that, because now we're all operating within the same environment and whatnot. All right. So I've talked a lot about why I like to use Docker and some of the problems with using just virtual environments or sharing packages or even pip freezing and moving on. You may not know what Docker is. Once again, this is not a Docker class. I am not even close to qualified to teach a good Docker overview. But what I want to talk about here is very high level. So from a high level concept of Docker, each container, so if you look over here, right, and these are all my containers right here. Those are all different versions of Linux. Each container is basically a mini Linux operating system. Yes, I know there's Windows, already covered it. Today I'm talking Linux. But every container is a minimal operating system. So it holds just enough to operate Linux. That's it. And it does CPU sharing, memory sharing through Docker. The Docker runtime manages that, and yeah. So as an example here, here's my Windows machine. I'm running Windows. I have WSL Ubuntu. Within that, I have Docker, and then I have these 3 individual containers. The great thing too is every container is isolated. These containers do not talk to each other. By default, all container ports are closed. Containers only save information to their container space by default. There's ways around that. So a container can talk out, but by default, the port's closed coming in. So you have to open that port. So everything is isolated. And I think it's also important to understand that containers are ephemeral. They are meant to be disposed of. When my container is done, all the data within it goes away. And that's perfect. There are ways to around that, because for development, we don't want our code to go away when we delete the container or when the container stops running. We want to be able to still access that code. And there's ways I'm going to talk about that. You use containers, you build a container using an image. Some of this stuff, this is high level, and you build images using something called a Docker file. A Docker file is just straight YAML. So it's very, very easy to use. And for development, it's really easy to use Docker Compose to build that to have that Docker file build an image, which builds your container. So it's kind of this chain of events. So once again, very high overview, and that's perfectly okay. So what I'm going to go ahead and move into now is kind of that high level overview. So we're going to look at a Docker file real quick. So give me 1 second here. I'm going to pull up our Docker file. All right, here's our Docker file. And we'll just, yeah, so this one's fine. This one's down in here. So this is what a Docker file looks like. It is nothing more than a set of instructions. And as you can see here, sorry about that. Now here we go. That's a little bit better. All right. So, and as you can see here, we have this from. That from, we're pulling a specific image. In this case, it's the Jupyter SciPy Notebook. And I'm going to talk more about, and so let's just go ahead and break down that line. So from Jupyter SciPy Notebook. So how do we get there? Well, we're going to go ahead and we're going to just go over here to Jupyter, or Docker Hub rather. So Docker Hub is a place where you don't have to, you can store your Docker images. Jupyter, so if you've used Jupyter Binder, if you've used Jupyter at all, they run their own Docker images. So if you've gone to the Jupyter Binder site, they actually use these images here to build your own little binder. And so as you can see here, when I talked earlier about from Jupyter SciPy Notebook, I was actually pulling from theirs, and that's how you pull it. That's the line right there. And so I can pull that in within my VS Code. 1 second there. As you can see, from Jupyter SciPy Notebook. That's awesome. So what does that mean? Well, let's go ahead and read into that, because this Jupyter SciPy Notebook, as you saw, there's a lot of other notebooks. There we go. Sorry, I'm all over the place here. So we have a TensorFlow notebook. That's pretty much built for you. You just got to do a little bit of work. The Data Science Notebook, Spark, PySpark, SciPy. I use SciPy for most everything. That's basically your scikit-learn library all within one. There's a Jupyter R notebook. So if you're an R user and you want to use Jupyter, it's already ready to go. You don't have to use Python. Minimal Notebook and Base Notebook, these two kind of build upon each other, and there's a couple others in there. So if you go to the Read the Docs site, and this one's pretty important because this tells you, okay, so everything is built, you can have images built upon images. And once again, if you're a little bit confused by that, go get a Docker class. They're amazing. I'm a huge fan. See here, I'm going to show you. I am wearing my Docker shirt for today. I am that big of a fan. All right, sorry. Okay, so within this Jupyter-based notebook, what's installed? Well, you get MiniForge, you get Conda, you get Notebook, you get Jupyter Hub, and Jupyter Lab packages. Basically, this is the minimum that is required to run Jupyter. It has nothing else installed with it. No pip install in anything. You'll also notice here that you're going to be operating under the Linux user Jovan. Docker containers by default run as root. That's very dangerous. So this is good because because you will be running as it'll create a user and make that user Jovan, which you will be running under. Honestly, it means really nothing, but it's good to know, especially if you're trying to path to folders. So let's go ahead here. Your art notebook, okay, has everything from minimal and has everything from above it. And it has all these packages installed. It has all these R libraries. It has Caret, R curl, Markdown, Shiny, Tidy Models. So a lot of the R packages a lot of people use. So for me, this is one I use most oftentimes. So it's SciPy is what they call it, but it's basically your scikit-learn library. It has Seaborn, and it has Matplotlib, Numba, Pandas, NumPy. It has SQL Alchemy, it has everything. If you're TensorFlow, it has everything in Jupyter. It has TensorFlow installed into it. Let's just say you want the full data science experience. They have the Data Science Notebook, which has Python, R, Julia, ton of stuff. It's very heavy. So I've ran this notebook before. It's like about 2 GB, which in the world of Docker is huge. A 2 GB container is like the largest container. I have one I built for not NLTK but NLP processes, and it is very heavy as well. So, and here's the great thing. So let's go back up here to SciPy. So within SciPy, when I say from Jupyter SciPy Notebook, I'm going to transition back here. I am downloading that image that has pandas, NumPy, everything in it that I need to run Scikit Notebook, which is awesome. And I'm going to minimize all this stuff now, just so you can see. All right. So when I talked about when a container runs, there's no data in it, right? We have to move that data in somehow. And I'm just going to bring this over here now so we can see it. So here's, if you look over here, Jupyter Docker, okay, actually backwards. All right, there we go. Now we're on track. So here is that Docker file I wrote right there. I'm copying. So for me to move data into that Docker container, I have to tell the computer, when you're building this container, I need you to copy a file. So in this case, we're going to copy my requirements.txt into a specific folder with the environment, into a specific folder within the container, and then we're going to tell it to basically pip install. And then I'm changing my directory. The workdir is just change directory. So that is basically how you can get a very simple notebook up and running right away. And here's your requirements file. Okay, this one's a horrible one because I don't have any requirements in it. So now what's bad too? Okay, here's a good one. So here's a requirements file, right? I needed PyMongo for this project. I needed Pydantic, and I was doing some environmental variables. So I brought in my environment. I bought python.env in as well. So I was able to bring all this in, and it works really great. So there's my requirements file. And then let's say you need a little bit more. Let's just say that within that Docker container, you need to install a specific program, and this has happened to me. So here's a Docker file I was using for an NLP. I called this my NLP Docker file. So as you can see here, just a little bit different language, but it all kind of looks the same. So base container was SciPy Notebook. Awesome. As you see here, I had to change my user to root because I needed to install some stuff. And this was really here. So I did pip install spaCy, and then I did a conda install of NLTK and Gensum. And then down here, I had to install the NLTK libraries. I just brought in the popular ones, and I had to bring in the spaCy core web language libraries. And this is what made it heavy. So, but when this container built, I had all of this stuff in one environment just ready to go, and it was perfect. So now I know you're wondering, okay, you've kind of bought into the concept. How do I at least get started without having to really get a Docker class? Well, go get a Docker class. It's going to help you more. It's going to hurt you. But this is how easy it is from scratch for me to start a project, even if I just want to test a script. Just play around in Jupyter, okay? So we're going to see here. All right, there's that stuff. All right. There's my notebook at. There we go. All right, so there's that. Okay, so let me zoom this up a little bit more just so you guys can see it better. That didn't work. That did the opposite of what I wanted it to do. All right. Hopefully that's a little bit better. A little bit more. Okay, cool. So here's that folder, and I'm running WSL and Windows Terminal. It's just something I like to run. But as you can see up here, we have Docker Compose, we have Docker, we have a README and requirements, right? It's the same stuff I showed you earlier. It's that same folder. There are no requirements. But the easiest and simple way for development purposes only, if I wanted to do this, I can just say Docker Compose. I forgot to go over Compose. I'll do that in a second. And I'll say, that is not words, build. Okay, so let's go over the Docker Compose function before I get too carried away. Docker Compose is kind of only used in development. All right, so the concept here being that you're not going to deploy this to a production machine. You're not going to deploy an application. This is just you. So you're building so this is instructions on how to deploy that container within this specific environment. All right, so let's go through this. So you're using version 3, you're calling it something context. The context is where is that Docker file located? Well, I just put a period because my Docker file is right there. Okay, so it's saying basically your Docker file is located here. Use this for most of the build. However, within the development environment, we have a couple things we need to change. I like using Jupyter Labs as opposed to the straight notebook. So here's an environmental variable I changed. I just say, hey, we're using Jupyter Lab. Volumes. Volumes is how I can work with data inside the container at the same time externally. And really, this is just kind of like almost a shared drive between the container and my current laptop. And then ports. Because I'm using Jupyter Lab, I have to use a port to access the web page. So this is just a simple port mapping. Now, this is host is on the left side, container is on the right side. So always remember host left, container right. And as you can see here in that volume mapping, I'm saying, hey, everything in this current folder, map it to home, Joven, work. And that's a folder structure established by Jupyter, the Jupyter people. I just copy it. It's too easy. And here's the ports. And if I wanted to run a different port other than 8888, I could put any port I wanted to here, and it's going to map to the inside 8888 port. Okay, so sorry about that quick detour. I kind of forgot about Docker Compose, but here's what we're going to do. So the first thing you don't have to do this, but I always do it because if you have to change things in the Docker the Docker container later, you always got to run Docker Compose build. So we're going to do Docker Compose build. It's going to build. It's pulling down that Docker file and it's building all the instructions in, and that's what it's doing right now. It's just going through all the instructions. I might speed this up. We'll see how long it takes. Okay, so if you noticed in my previous, I kind of cut away real quick and then come back in while it was building everything. So as you can see, my screen was a little bit off. I fixed that. But it just went through and, oh, okay, Docker Compose build, and it goes through all these different steps. So it's basically using this container. And the cool part is let's say, as you can see down here, here's my copy requirements folder. And then I installed the requirements, which there were none, so it was very quick. And then I changed my work directory. Well, let's say I need to add a requirement. And you saw that kind of took some time to build. It wasn't exactly fast. It was 104 seconds. Well, let's go ahead and add in a requirement here. So I'm just going to go here. I'm going to be lazy. So let's just go ahead and copy in this pie. We're going to copy this into this folder. All right, we're going to save it. Now let's go back. All right, so I got to run Docker build again. Docker Compose build. Oof. All right. As you can see, it only had this last. I did something wrong. I'm using a wrong .env version, so we got to fix that. That's too easy. We're just going to do this. I'm going to say I probably did something stupid. That's fine. We're just going to take away the pinning, which is generally a bad idea, but for today it'll work fine. So as you can see here, as it was starting to build everything, it realized up till this point, nothing had changed. There was nothing to change. There was no re-downloads that needed to occur. However, when it got to pip install, it realized, okay, there is a change. So it logs that change as a hash. And then so it builds, it doesn't need to build up to here. It'll only build the change. but after the change, it has to rebuild everything. So things you change a lot, you want to put at the far end of your Docker container instructions. All right, so we've built the container. It's ready to be deployed. So really, all we got to do now is Docker compose up, and it's going to go ahead and it's going to start that container. And here you can see, okay, here's some stuff. Hey, if you want to access this file, and the easiest thing to do here is just click the link, and it opens up a web page. It takes a couple seconds to start, and look, here's all my files. There's the Docker compose, Docker container README requirements, and we're good. I can start my notebook here, and you don't want to pip install anything here. That I think that's the key, is like never use this for pip install. You want to pip install. You need to add it to your requirements and rebuild. Really easy process. But let's say we can say x equals 2, cool, and then we can just say print x. I can do import pandas as PD. And there you go. Import numpy as np. Done. And so you have all of that ready to go right there. And it's fantastic because now I have this really quick and easy development environment. And I can now, if I wanted to share this, right? So I'm just going to go ahead and save. I'm going to come back in here. I got to open this up. I'm going to just go ahead and hit Control C to stop the container. Yeah, we don't need to see me stopping. All right. So now if I go back to that Jupyter folder, you can see that requirements folder is right, or that untitled, that notebook I just built is right there. So if I had get and edit this, I could actually just copy these files, send them to a person. All they have to do is run Docker compose build, Docker compose up, and they have the exact same environment. And if you're running this off of GitHub and GitLab and all that, here you go. There you go. So I went ahead and built this. I'll include a link in the description. But this is really all you have to do to share your code now. Is just bringing that in. And I'm going to go ahead. Let's go ahead and say I was working some other stuff there. I was working a Titanic project that I built entirely inside of Docker. E2E Titanic. Yes, this is me being prepared. Oh, that's in GitLab. That was my problem. I have that project in GitLab. So we're just going to go down here and E2E Titanic. So here was a whole project I built using a Docker dev environment. And I have this folder structure built out where I have all my test data, right? So I have all this on in a GitLab instance. Kubernetes was for deployment of something. Here's all the notebooks I built. My EDA, my data imputation, pre-processing, model training, my validation against the Kaggle dataset, model performance. I was running some fake data just so I could test an API I built with it. Workbench, just as I always have a workbench where I just have scripts when I'm just kind of trying to get a script or a function written correctly. That's just kind of where I build it. Then here within this source directory, I actually have sub-Docker files, which I built where I built a fast API for the model. But I can give this folder to anyone and they can run with it. They're good. This is on GitLab, which is I don't have up right now, so I can't show you. But that is really the benefit there, is just me being able to go ahead and going through and collaboration. It really does. I guess for me, it really came down to collaboration. I don't manage virtual environments. I can track my packages. It's easy to collaborate. And while I didn't go through it in this example, because I have a Docker first mindset, everything I do is ready to be deployed. And because I deploy into containers, therefore, if you can deploy to a container, you can deploy into a Kubernetes environment, which is a different discussion, but is really important on how can we scale our models? How can we scale APIs? Well, if I build in Docker, it's pretty much ready to go from that point on. All those little Dockers, when you're taking a project and making it into a container, all that goes away because all that work was already done on the front end. So kind of, I guess that wraps it up for me. I really appreciate your time. This wasn't really meant to be a hands-on or a Docker class. This is just kind of showing how I use Docker for development. But thank you.